Hey guys, what happens when you combine solid aluminum and put it into a solution of copper sulfate? Well, what happens is the aluminum bonds with the sulfate instead to make aluminum sulfate, and the copper comes out as a solid. We can explain how this happens using electrochemistry, and the first way that I want to explain it involves using the oxidation numbers to see what's happening to each atom individually. You know how to find oxidation numbers. The oxidation number for an element in its standard state is 0. And so this copper also has an oxidation state of 0. The sulfate anion has a charge of -2, which means this copper has a charge of +2 to counteract it, since the whole thing is uncharged. And these three sulfates have a charge of oxidation state of -2 each. Thus we have -6 in sulfates. We need +6 in aluminums, but there are 2 of them here. Each aluminum is +3. So what do we have going on here? We've got aluminum solid being converted to aluminum 3+. Where'd the electrons go? Well, the electrons were here, since this is a neutral entity, but they're gone here because this is now a positive. This aluminum split up into its aluminum 3+, and it gave off 3 electrons. The copper, on the other hand, started as 2+ and ended as an uncharged species. See, Cu2+, Cu. To do that, it had to combine with 2 electrons. In this case, 2 electrons plus a copper 2 ion make a copper uncharged atom. Now here's the deal. Each of these isn't a real chemical reaction because it isn't 2 chemicals interacting with each other. Nothing's changing its chemical form except for the fact that an atom is changing its charge/oxidation state. This aluminum reaction wouldn't have happened without the copper to absorb the electrons, and this copper reaction wouldn't have happened without the aluminum producing the electrons. These two combine to make an overall reaction. Now, really though, we're going to have to make sure that our electrons cancel out, because I've never seen an electron in a chemical reaction. I'm going to need 2 of everything on this line and 3 of everything on this line. The reason is now I have 6 electrons on the right-hand side and 6 electrons on the left-hand side. The electrons will cancel each other out, and I'm left with 2 aluminums and 3 copper 2s, making 3 coppers and 2 aluminum 3+. This is the reaction that's actually happening here. See? Aluminum and copper 2 makes copper and aluminum 3+. Each of these reactions that I've written in blue are called half reactions because they only tell half the story of the overall redox reaction. Later, we're going to be figuring out how many volts a particular redox reaction gives off. But to figure that out, you're going to have to look up each of the half reactions